The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
We want to turn this course to now start talking about some normative economics, which is how do we feel about the actions firms and consumers take. And to do that, we need to pause and, starting last lecture, now through this lecture, talk about welfare, well-being. How do we measure the well-being implications of individual and firm actions? Now, we talked last time about the first concept of this, which was consumer surplus. Okay, consumer surplus was the amount of utility consumers derived above and beyond the price they had to pay for the good. Now, since utility, remember, is not ordinal, it's cardinal, we redefine that then as the consumer's willingness to pay above the price that they pay for a good. So anything the consumer is willing to pay that was higher than the price they actually paid is consumer surplus. Okay? And that was at the individual level. That was individual consumer surplus. Now what we want to do is move on and talk about market consumer surplus. So for an individual, consumer surplus is a willingness to pay above the price actually paid. At the market level, it's the same thing. Okay, it's just the aggregation of individual consumer surpluses. Okay, so let's think about a simple example. Okay, let's think about the case of the consumer surplus that you derive from my lectures. Okay, let's think about the consumer surplus you derive from my lectures. So we have some demand curve for my lectures, and let's look at figure 13.1. Let's say it's the demand curve for my lectures. Okay, so basically, this is a willingness to pay. So the notion is that there's some student who's willing to pay a large amount because they recognize the brilliance of what they're hearing here, and they're willing to pay a large amount for my lectures. Then there's the next student who's willing to pay slightly less, all the way down to the student who falls asleep every time who's not willing to pay anything for my lectures. Okay? So you've got some demand curve for my lectures. And once again, the key to all this, the key to the welfare analysis, is to remember what this demand curve represents. It's a willingness to pay curve. But in this case, it's not an individual's willingness to pay, it's the market's willingness to pay, where each point is a unit of demand. So in this case, one unit equals one person. So each point represents the willingness to pay of that person. So the point on the y-axis represents the willingness to pay of the person who most enjoys my lectures or derives the most value out of them. The intersection of that line with the x-axis is a willingness to pay of 0. Someone's not willing to pay anything for the lectures. Okay, obviously, it could go negative. People could be willing to pay not to have to come to lecture, but we won't consider that. We'll just say 0 is the minimum. Okay? So basically, what is the key determinant of the equilibrium outcome? It is the point where equilibrium is the point where the price is set equal to the willingness to pay of the marginal consumer. So think about a typical supply-demand, diagram, and we get some equilibrium price. Okay, so here's our equilibrium quantity Q star, and here's our equilibrium price P star. Now let's focus in on this demand curve. What that price P star, it represents, it's on the demand curve. So it's a willingness to pay. Whose willingness to pay is it? It's a willingness to pay of person Q star. It's a willingness to pay of the person who's exactly willing to pay the price. That is an equilibrium in a perfectly competitive market, okay, of the kind we've discussed so far. The price represents the willingness to pay of the marginal consumer, the willingness to pay of the consumer who exactly is indifferent between consuming and not consuming the good. So this consumer Q star, this person Q star in our example, okay, is the person who's indifferent, who derives what? 0 consumer surplus. This person, since their willingness to pay equals the price, equilibrium is achieved where the price is set at in equilibrium. You have that the marginal consumer, the last person consuming, is deriving 0 consumer surplus. They are indifferent between consuming the good and not consuming the good at that price. If it was free, they'd be happy to consume it. But at the price, at that equilibrium price P star, they're indifferent. Okay? So basically, if you look again at the diagram, What this is saying is that the price was $100 a lecture, okay, then person 100, that 100th person, would be the marginal consumer who's indifferent between paying the 100 and hearing my lecture or paying nothing and skipping my lecture. Okay? So that person 100, okay, is the person who's indifferent between paying $100 and hearing my lecture or paying 0 and not hearing my lecture. That person derives no consumer surplus because their willingness to pay equals the price. What that means is that every consumer up to the first 100, by definition, must be deriving some consumer surplus. As long as the demand curve is downward sloping, every person to the left of person 100 must be deriving some consumer surplus. In particular, the first person is deriving enormous consumer surplus. How can we prove that? Well, the proof is simple. We know their willingness to pay is higher than person 100. We know the prices, and we know person 100 is willing to pay $100. Therefore, by definition, anyone to the left is deriving consumer surplus from this, okay? Because we know they like it more than person 100, and person 100 is willing to pay $100. They only have to pay $100. It's one price to everybody. So by definition, they're deriving consumer surplus, okay? So the first guy, he gets a big consumer surplus. He or she gets a big consumer surplus. Then it dwindles and dwindles and dwindles until the 100th person derives 0. But you integrate, and the entire consumer surplus for the market is that entire triangle, that entire shaded triangle. So market consumer surplus is defined the same as individual consumer surplus. It's the difference between the demand curve. It's the area under the demand curve above the price. So it's the integral of that area under the demand curve above the price. But here we're thinking of it not in terms of a person's decision, but the market's decision. And the way we think about that is the last unit being representing the person who's indifferent and everybody else deriving surplus from it. Okay? Questions about that? Now, let's ask, what then would happen if the price of my lecture rate rose? So let's say I was charging $100 at the door. You guys are all the guys to the left of person 100. Those people here for the first lecture don't show up anymore. They're the people to the right, okay, of person 100. Okay? And now let's say I change. Instead of charging $100 at the door, I charge you $110 at the door. So let's look at figure 13.2. Okay? What happens there? Well, in that case, if I charge $110, okay, the 100th guy is no longer willing to come to lecture. Remember, the 100th guy, he or she was indifferent between paying $100 and hearing my lecture or paying nothing and missing my lecture. Well, at 110, clearly they'll say, forget it, it's not worth it anymore. They'll drop out. Likewise, the way I've drawn this diagram, everybody above person 90 will no longer attend. That is, person 90 is now the person where at a price of 110, they're indifferent between paying and attending or not paying and not attending. Everybody to the left of person 90 still gets consumer surplus. It's not shaded, but if you shade the triangle above the 110 dashed line, okay, the triangle under the demand curve and above the dashed line at 110, that's the new consumer surplus. Okay, that's the new consumer surplus. Those people still derive consumer surplus because they love me so much that they're willing to pay more than 110. So even at 110, they prefer to pay 100. But even at 110, they'll still come and they'll still be happy about it. But now 10 people have dropped out because they're not willing to pay 110. They were only willing to pay 100. So what we see is that the total consumer surplus has shrunk. It's shrunk by this trapezoid, by the shaded trapezoid. Okay? And it's shrunk for two reasons. One reason is that some people who used to derive consumer surplus now are out of the market. That's the triangle. That's the shaded triangle. Okay? It's also shrunk because even people staying in the market are now sadder. They've lost consumer surplus. The consumer surplus is still positive. They're still coming to lecture, but it's smaller than it was, and that's the rectangle. Okay? So the triangle is the people who drop out of the market. Okay? The rectangle is the reduced consumer surplus. The reduced consumer surplus of people who stay in the market but now have to pay $10 more. The consumer surplus is still positive, but it's smaller. Okay, so question to you. What is the key economic concept that's going to determine for a given market whether consumer surplus is large or small? Yeah?
Elasticity.
The elasticity. And why is that?
Because it changes like how steeply.
Exactly. So if we look at figure 13.3, now here is a case with a steeper elasticity of demand, where consumers are more inelastic. If you compare it to figure 13.1, you'll see the consumer surplus triangle is much bigger. Likewise, if we drew a flatter demand curve, a more elastic demand, the consumer surplus would be much smaller. Okay? So hopefully you can see graphically what will determine consumer surplus is the elasticity of demand. Now can someone give me the intuition for why that's true? Graphically, I hope you can see it's true. The triangle will be smaller as that curve is flatter. Can someone give me the intuition for why that's true? Why is it the consumer surplus is larger the more inelastic is demand, and consumer surplus is smaller the more elastic is demand? You want to give it a try?
I guess if it's more inelastic, then consumers don't have...
They don't have what? You're on exactly the right panel. What determines it?
As many choices.
They don't have as many substitutes. So an inelastic demand is one where consumers don't have as many substitutes. In that case, they get a lot of surplus from consuming this good. So think about insulin versus McDonald's. Okay? The consumer surplus from insulin is very, very high, because regardless of the price, I die without it. And there's no substitute. So it's a very inelastic demanded good. And as a result, at any price, I derive a huge consumer surplus, because as long as that price is less than the value of my life, I derive a big consumer surplus. Okay? Now let's take McDonald's. Okay? I can always go to Burger King and be equally happy. Okay? Maybe not quite equally happy. The curve isn't perfectly elastic. I like McDonald's a little bit more. I like the prizes and their Happy Meals better. Okay? So it's a little bit elastic. But the point is, if McDonald's raises the price, I'm not that much sadder because I just go to Burger King, where I was perfectly happy as well. So there's not much lost consumer surplus if McDonald's raises the price. There's not much consumer surplus arising. There's not that much consumer surplus. No, forget the loss. Go back. That's a different issue. I'm talking the size of the consumer surplus. There's not much consumer surplus arising from consuming at McDonald's. Okay? Not much consumer surplus arising from consuming McDonald's, because I can always just go to Burger King instead. So what determines consumer surplus is the elasticity of demand, which is fundamentally about about your willingness to pay. Inelastic goods have higher willingness to pay. Okay? And so as a result, the consumer surplus is essentially inversely related to the elasticity of demand. The higher the elasticity, the smaller the consumer surplus. Okay? Now let's shift and talk about producers. Well, the analysis for producer surplus is exactly the same type of analysis, just flipped to the other side of the market. Okay? Now here the question is, what determines my producer surplus? Well, what determines consumer surplus? It's the difference between my marginal willingness to pay and the price. What determines producer surplus? That's going to be the difference between the firm's marginal willingness to supply and the price. So my marginal willingness to pay as a consumer is what determines my consumer surplus. Producer surplus will be determined by my marginal willingness to supply. Okay? My marginal willingness to supply, which is simply represented by the supply curve. A little bit easier for producer surplus. The supply curve represents the price at which I'm willing to supply a good. That's what a supply curve is. As we learned a couple lectures ago, in the context of competitive firms, that's my marginal cost. Okay? So the supply curve is my marginal cost. That says that is how much it costs me to produce the next unit. In a perfectly competitive long-run equilibrium, or short-run equilibrium, that is basically what I'll set my price to. Okay? So if we go to figure 13.4, okay? Now let's look at my producer surplus, my surplus from delivering lectures. Okay, let's say that, this is a bit harder to imagine, but imagine that I prefer to deliver smaller lectures. Maybe because as the kids get small, number of kids get small, I can learn your names. I don't have to look around as much, I don't have to pace as much, whatever. Okay? So imagine that I'm most happy delivering a lecture to one student, and that's the lowest cost to me, the lowest effort. I can just come in and sit down, and we have coffee, and I just riff, and I don't have to worry about notes or any of that stuff. But when there's 2 students, I feel a little bit guilty doing that, so I make some notes to myself. When there's 3 students, I make some more notes. By the time there's all you students, I have to type up all these notes. Okay? So every student that add to my lecture, okay, imagine there's a marginal cost. Now, you know that's not true, of course. I wouldn't change my notes if 6 more students walked in. But let's just imagine that it's linear. Okay? Imagine with every student that comes in here, I have to put in a little more effort in my lecture. So that's a marginal cost to me of the additional students. Okay? So that delivers this supply curve, this upward sloping supply curve. Okay? Now let's say at a given price P, I'm willing to lecture. So that, given that supply curve, if the price is equal to P, I'm willing to lecture to Q students. That is, if you're going to give me a price of P, at that price, my marginal willingness to supply is that I'll supply Q lectures. Okay? So or in other words, another way to say it is if you want me to supply Q lectures, you've got to pay me a price P. That's the point where I derive no producer surplus. I'm indifferent at that point. If you said, at that point, if you said, would you be happy to have a Q, would you want the Q student or not? I'd say, I don't really care. I make 0, I'm indifferent. I get 0 producer surplus. But I got a huge surplus on that first student because I was willing to work with them and it wouldn't have cost me anything. But I'm getting paid P to work with all of you. So I make a producer surplus on that. So producer surplus is made on every unit to the left of Q. Because those are units with a positive producer surplus. They're the units above the supply curve and below the price. They're the units where it's above the supply curve, so I'm willing to supply, but below the price, which means that I'm getting paid more than I would have to supply that unit. Can anyone think of what another name for this triangle, roughly? How else you might think about that triangle? If I hadn't talked about producer surplus and I said, what's the difference between the price producers receive and the cost that they have to produce it? Profit. Roughly speaking, producer surplus is profit. Now, technically, in the short run, that's not true, because in the short run, there's fixed costs, and you might lose money on fixed costs and still make a long-run profit. So in the short run, it's not technically true. In the long run, it is technically true, and for the purpose of this course, we'll say it's technically true. So producer surplus is profit. It's a lot easier to think about. Consumer surplus is this vague concept where you have to measure my willingness to pay versus what I pay. Producer surplus is easy. It's profit. Okay? So producer surplus is profit. It's the difference between what the price at which I'm willing to produce the good and the price you actually pay me for it. Okay? So that's producer surplus. Questions about that? Okay. Putting this together, we can now measure the total welfare of society. We now have it. We can measure the entire happiness of all of society. And we define social welfare of society as consumer surplus plus producer surplus. Now, that doesn't have to be. You could say, gee, John, don't you care more about consumers than firms? Or, gee, John, don't you care more about firms than consumers? I'm going to leave that alone for now. We're just going to do the simplest thing and just say, we're going to define social welfare as simply the sum of how much surplus consumers get plus how much surplus producers get. Okay? This is a particular representation. When we talk about efficiency and equilibrium, we talk about efficiency, versus equity, which we'll talk about towards the end of the course. We'll talk about alternative definitions and how we weigh different definitions of this. But for now, this is the standard economic definition, which is let's not draw a judgment about who's better than who. Let's just talk about the total amount of surplus in society. Okay, so that's the total amount of social welfare is the total amount of surplus in society. And here's the key result. That the competitive equilibrium, where demand equals supply in competitive equilibrium, is the welfare maximizing outcome. That competitive equilibrium in the market, which is where demand equals supply, is also the welfare maximizing outcome. Okay? And that's the key thing we want to go to now, which is that basically moving away from that equilibrium point where demand equals supply will by definition lower the amount of social welfare. Okay? So to see this, let's go to figure 13.5. Okay? And we've got some supply and demand curves. This is from the book now. We've got some supply and demand curves. And we're initially in equilibrium at P P1, Q1 at the point E1. So initial equilibrium at E1. Okay? At E1, okay, at that initial equilibrium point, consumer surplus is equal to R, now going by the letters that label the areas, R plus S plus V. That's the amount of consumer surplus, the amount under the demand curve above the price. Right? That's once again, stop me if this is not clear. This is important stuff. So this is the amount under the demand curve above the price, R plus S plus V. The producer surplus is T plus U. The profit is the amount above the supply curve and below the price. Okay? So total social welfare is the sum of all these, R plus S plus V plus T plus U. Okay? That's our starting point. That's our competitive equilibrium starting point. Now, let's see, you should be able to immediately see, those of you who are good with your geometry, that there is no point you could choose which can make social welfare larger. As a simple comparative statics exercise, imagine I had the government come in and say, we're going to raise the prices market to P2. We decide that producers aren't making enough. Look, the consumers get 3 letters. The producers only get 2 letters. That's unfair. So we're going to raise the price and give the producers more letters and the consumers fewer letters. That sounds like about the rational base for government policy making these days. We're going to do that. And so we're going to raise the price to P2. Well, the price of P2 will have a new equilibrium. Okay, if you force the price up to P2, okay, you'll have a new equilibrium at little e sub 2, okay, and a quantity of Q2. What happens now? What's happened to consumer surplus? Consumer surplus, you've now lost S and V. Okay, consumer surplus is now just R, because at that new price P2, that's the area under the demand curve above the price. Producer surplus has grown, however. Now, instead of being T plus U, it's now T plus S. So what's happened effectively is you've transferred S from consumers to producers. And you've lost V plus U forever. Okay? So what's involved in this change is a transfer and a loss. The transfer is the area S, which used to belong to consumers, now belongs to producers. But now we have what we call a deadweight loss. Deadweight loss of V plus U. That's welfare that has disappeared. Welfare has disappeared. And the definition of deadweight loss is a net reduction in efficiency from trades that are not made. Remember we talked about efficiency early on in the course. We said that efficient outcome is one where trades that make both people better off are made. Okay? Here we have trades which, absent the government, would have made both parties better off. And they're not happening. That is surplus that's just gone. It's into the ether. Okay? That is social surplus that is now social welfare that is now gone because there are trades that would have made both parties happier that are now not happening. And that's a total waste from society's perspective. Because society's best off if all the trades that make both parties happier happen. Okay? So the bottom line is any price you would impose other than the market price of P1, and you can work this out for yourself, any price you would impose would by definition, okay, would by definition lead to a lower social welfare. It may shift. It may lead to a bigger or smaller consumer surplus relative to producer surplus. Once again, at this point, we're just using the sum of them as our measure of social welfare. Social welfare has fallen. Okay? So social welfare is maximized in this case. So what this gives us sort of a framework to think about we started the course with. We started the course with supply and demand and talking about how things like the minimum wage reduce efficiency. Well, this gives us a welfare framework, a more formal welfare framework for thinking about that. I said it reduced efficiency before because you had less labor in the market. But now we can actually more formally say, why does the minimum wage reduce efficiency? Well, we can actually look at that. Let me just do the always risky thing of trying a freehand diagram. Okay? You remember our market for labor. You had the amount of labor on the x-axis the wage on the y-axis, okay, you had some supply of labor. That comes from workers deciding to work. As the wage goes up, they want to work more. You've got demand for labor. That comes from firms demanding workers. As the wage goes up, they want fewer workers. And you have some initial equilibrium, L star, W star. When the government came in with its minimum wage, and the government said, we're going to impose a minimum wage of W bar, W super bar. Okay? Remember we said what happened was, well, of course, then firms are only going to want L1 workers. Okay? Or we're going to want L1 workers. We talked about before is just how that led to some unemployment. Okay? What we didn't mention is how this leads to an efficiency loss to society, which is this area is now deadweight loss. These are workers who would have been happy to work at the prevailing wage, and firms who would have been happy to hire the workers at the prevailing wage, and those trades can no longer happen. Okay, so here's an important question to help you think. You're going to have to draw deadweight loss triangles like in your sleep now. So here's the trick with these. Okay, why is the deadweight loss triangle smallest here and grow like that? Why is the deadweight loss triangle grows as you move away from the competitive equilibrium? Yeah?
Because the least amount of people are willing to work for that really crappy price.
Say it again?
So there's less people that are willing to work for that smaller price.
For this, well, here we're imposing a higher. Less people are willing to work for, well, you've heard it here or here?
To the all the way to the right.
All the way. So basically the point is, another way to put it is at that wage, the consumers there are pretty indifferent. So in other words, it's not they're willing to work but barely. Okay, so basically at this wage, at this point here, okay, the L-starth worker is getting no surplus from working. It's not a crappy wage. He's happy to take it, but he'd also be happy to sit at home. He's indifferent. So if you move for that L-starth worker, if you make him not work, he doesn't care. So if you raise the minimum wage and this guy sits at home instead of working, he didn't care. He was getting no surplus from working anyway. Likewise, this firm who's hiring the L-starth worker, they were paying that worker exactly what he was producing. The marginal cost of that worker exactly equaled what they're paying him. What that worker's producing exactly equal what they paid him. They were earning zero profit on that worker. So they don't care if he stays home. So if the government set a minimum wage such that one guy stayed home, the minimum wage was so close to the market wage that one guy stayed home, there would be no social welfare loss, or an infinitesimally small. Because that last guy, there was indifference on both the worker side and the firm side. However, once you start displacing more and more, these workers aren't indifferent anymore, right? These are workers who are making a lot of surplus at that wage, and firms who are earning a lot of profit at that wage. Now they're not indifferent. So as you move farther and farther from the competitive equilibrium, the distortion gets larger and larger. Very important intuition to have. That for that last person, there's no distortion for moving epsilon away from the competitive equilibrium, because they weren't earning any surplus anyway, and the firm wasn't making any surplus on them. But as you move away, the loss in social welfare gets larger and larger, because these are people who are making all sorts of surplus from these transactions, and you're stopping them from happening. So if the government interferes with the transaction, okay, so imagine this guy and I were negotiating over a baseball card, and I ended up paying him exactly what the baseball card was worth to him, and I ended up paying exactly what it was worth to me to have it. And then my parents come in and say, you can't do that, okay? Then it doesn't really matter, because we weren't making any surplus off that trade anyway. But if he had 3 of these cards and was delighted to get rid of it for 50 bucks, and I have always wanted this card and value it at 200 bucks, then if my parents come in and say this trade, then that's a real bummer, okay? That's a huge loss in social welfare, because the trade that made both parties better off is not happening. Questions about that? Okay, let's look at a particularly good example of this, okay, of when the government interferes with trades and the implications of that. The TAs on Friday are going to go through a bunch of interesting examples. I'm just going to do one today, and then you do some more in section, because this is hard and important. I want to today focus on the example of taxicab medallions. It's an example in the book, which is a particularly good example. Okay, taxi drivers, we all taken taxis. We know how they work. But taxi drivers in virtually all cities, you cannot just start a cab and drive people around. in virtually all cities, you need to get something from the city that allows you to call yourself a taxi cab. Okay, and that's typically called the Taxicab Medallion. It originally was just literally something you had on the hood of your car. Now it's a certificate you have in the back of your car. So you see the certificate whenever you ride in a car, which says, you know, so-and-so is licensed by the city of whatever to drive this cab. Okay? The government issues a certain amount of these taxicab medallions and almost always issues less than would be demanded in the free market for taxicabs. And let's see what effect that has. Okay? So go to 13.6. This is getting kind of complicated, but it's an example of the kind of welfare analysis we can do once we understand these concepts. Okay? Let's say we start at point E1. Big E1 on the right, little E1 on the left. So the right-hand side, this is like our other profit diagrams. The right-hand side is the market. The left-hand side is an individual cab firm. Okay? Initially, if the government does interfere, you are in equilibrium at point big E sub 1, which is that there's the price is P1. An individual cab firm delivers little q sub 1 rides, and let's assume cab firms are identical, just to make it easy, and that there are n of them. Well, in that case, the total amount delivered is n1 q1. So big Q sub 1 is little q sub 1, which is the amount delivered by a given cab firm at that price, times the n cab firms in the market, n1 cab firms in the market. Okay? So there's n1 firms, each delivers little q sub 1 of rides. And they make, and you can see at that point, they each make some profit. Okay? So what you can see at that point is that at E1, at a price of P1, they are making some profit. Okay? The price is set equal to their marginal cost. No, I'm sorry, they're not making profit. My bad. You see at that point they're not making profit because what you can see is price is equal to the minimum of average cost. Right? Remember the no profit condition is where marginal cost equals average cost. You can see at that point, little e1 in the diagram at the left, okay, there is no profit because price equals marginal cost equals average cost. So making no profit, and that's the perfectly competitive equilibrium. That's what we derived last time. Now let's say the government comes in and says, you know what? We are going to, and the welfare here, just do the welfare here, you see that the welfare of society is producers make no surplus. There's no producer surplus, there's no profits. Consumers have surplus of A plus B plus C. Okay? So consumer surplus is the area on the demand curve above the price. That's A plus B plus C. Producer surplus is profits, which are 0, because it's perfectly competitive. So you end up with a total social surplus of A plus B plus C. Okay? And it all goes to consumers. Now let's say the taxi cab owners aren't so happy about this. They don't like making 0 surplus. And they managed to get a restriction such that the government says only a certain number of medallions, and we're only going to let people drive the cabs if they have a medallion. Okay. Now let's say that the taxi cab owners say we're only going to limit the number of medallions to n sub 2. Instead of there being n sub 1 cab firms, let's say the medallions aren't for cabs, they're for cab companies. Instead of being n sub 1 cab companies, we're going to limit medallions so there can only be n sub 2 cab companies. So what happens? Well, it's a little complicated, so let's follow along. If there's only n sub 2 cab companies, then what that means is that given the same market demand, that means firms are now going to be able to make some profit. Okay? So if you look at the right-hand side diagram, up to N2Q1, the supply curve is the same. But at that point, once you pass N2Q1, then you have a point where that's all at the old efficient level of cab rides. The efficient level is each cab company provides Q sub 1 rides. Well, you've then run out of rides, but people still want more. So what happens? Well, cab companies start to be able to charge more. Their supply curve becomes upward sloping. They start to be able to charge more for their rides because now you don't have extra cab companies entering and competing those profits away. They start to be able to charge more for their rides. And you see that upward sloping supply curve meets the demand curve at N2Q2. Okay? So up to N2Q1, it's the same supply curve it was, which is flat. Once you get beyond that, now firms can charge a higher price because they don't have to worry about entry. So you get a new supply curve that's flat until N2Q1, then starts to slope up. That's S super 2. And S super 2 intersects the demand curve at point E sub 2. And that is the new equilibrium, with a higher price of P2 and a lower total quantity of Q2, big Q2. Now let's look at what that does to the firm. Well, a given firm at a price P2, okay, they always set price equal to marginal cost. That's the rule. Every profit maximizing firm does that. Well, they now are at a point little e sub 2, making a huge profit. Because at that point, their marginal cost is well above their average cost. So at that point, they make the profit of the shaded area pi in the left-hand side diagram. They make the profit pi. Because once again, is go to the right hand, then back to the left-hand side. The right-hand side is the new supply curve, intersects the demand curve at point E2. That's a price of P2. Carry that over the left-hand diagram. You see at a price of P2, they make a profit of the difference between that price and the average cost curve, which is that shaded pi box. So firms now make profits, and they didn't before. What's happened to welfare in the market? Okay? Well, what's happened is consumer surplus has now fallen from A plus B to just A. Because the price is now P2, the consumer surplus is the area under the demand curve above the price. That's just the triangle A. Okay? Just the triangle A. At that new price, that's a consumer surplus. What's the producer surplus? Well, now producers are making profits, and what they're making in surplus is the area below the price above their supply curve. The supply curve is this funky kinked thing I just described. So their new producer surplus is this, I don't know what the name is for like a trapezoid with a curved side. Does that have a name? Still a trapezoid? I don't know. Anyway, curvazoid. B. Their new surplus is B. So producers now make surplus B. Consumer surplus reduced to A, and what's happened to C? C is gone. C is deadweight loss. Consumer surplus is now A. Producer surplus is now B. The darkly shaded area C is now the deadweight loss. And that's the deadweight loss because, once again, at the old marginal cost curve, at the old supply curve, these are trades which both the producer, which is a taxi cab company, and the consumer, which is the person riding the taxi, were happy to make. And they're not being made now. So we've now lost an amount C deadweight loss. Okay? Sorry about the confusion. Questions about that? Okay. Now, here's my question for you. You can go home and think about that, and hopefully it'll be clear in the examples on Friday. But let's ask a slightly deeper question. Does this mean that if you become a taxi driver today, you will derive producer surplus of B from driving a taxi? Why not?
Because you have to pay that lump sum in the beginning.
Because the point is, you have to get into the market, and to get in the market, you need a medallion, and the guy who's the medallion isn't just going to hand it over to you for free. So let's say this guy's retiring as a cab driver. He's got his medallion. You come up to me and say, I want to be a cab driver because I see this big producer surplus area B. Okay? Your medallion. What's this guy going to say? He's going to say, well, wait a second. If I give you my medallion, you're going to make net profits of pi. Right? That's the profit you make by being a taxi driver in this market. So what should he do? Same part. What should he do? He should sell it to you. And how much should he sell it to you for? Pi minus a penny. And you might say, well, that's ridiculous. I won't pay pi minus a penny. Then I'll make nothing. Well, but he will. He'll pay minus a penny because at least he'll make a penny. Okay? Now you might say a penny, $1, $5, $10, whatever. But the point is that he'll sell it for very close to pi. Because there's someone out there who's willing to pay close to pi to get that. As long as there's a little bit left, so he'll sell for a little bit less than pi. Okay? They'll pay it. But what that means is, having paid it, you don't make any money. So let's say there's let's do the extreme example where he can sell for $1 less than pi. Okay? What that means is, you having bought it for $1 less than pi, you don't make any money as a cab driver. So wait a second, this is weird. We've just restricted the market. We've said there's all this profit to be made, and yet you're a cab driver and you make no profit. What happened to the profit? Who got it? The cab drivers who were originally issued the medallions. The first generation of cab drivers who got the medallions got all the money. So in fact, taxicab medallions do nothing to the living of taxi drivers. All they do is enrich the set of people who originally lobbied for them and got them. Okay? Yeah?
But wouldn't he make his money back the second that he sold it? Given that he can get the same price for his money.
Wouldn't he? No, but the point is that basically what he's done, oh, you're saying when he goes to sell it. So in other words, the taxicab medallion is worth a certain amount of money. Okay, but that would be embedded in the money he would charge you. Okay, so he's not dumb. He straightened me out in the supply curve. He's a smart guy. He should have picked someone else to negotiate with. Okay, he's going to say, look, I'm going to charge you enough so that you'll only make $10 forever on having this. I'm going to charge you enough so that basically you will not make any money, even when you go to get rid of it. Okay, so that basically what you'll do is you'll have to pay him so much. So let's say the way it works. So let me give you an example. Let me come back to that in the context of example. So what we know is that basically, and this is in Perloff, he has some interesting facts on this. We know that taxicab medallions are really limiting. Like, for example, we know that Tokyo has 5 times as many cabs as New York City, despite the fact that New York City is bigger than Tokyo. And Washington, D.C. has 10 times as many cabs as San Francisco, despite the fact that Washington, D.C. is smaller than San Francisco. I'm not from San Francisco. You can always get a cab in Washington. I know hardest to get in San Francisco. But there's 10 times as many cabs in Washington. And this is reflected in the value of a permit. So in San Francisco, okay, what you do, and this is sort of it's hard to think about the resale. It's an easier way to think about it. What he does is he doesn't sell you the permit. What they do in San Francisco, they don't sell it. He rents it to you. So you never get to own it. He rents it to you. And in San Francisco, the typical permit costs $42,000 a year to rent. So if you want to be a cab driver, you've got to pay $42,000 a year off the top before you earn $1. Okay? And then he rents you. Then when you're done, he takes it back. So in some sense, the way, now if he was selling it, I can describe it to you, it involves the fact that he would embed your future asset value in his sale price. That involves some complicated finance we'll get to later in the course. So think about renting it, that's easier. He'll rent it to you for the entire surplus pie, or pie minus $10. In San Francisco, that amounts to $42,000 a year. In New York originally had 12,000 permits they issued. In 1937, they issued 12,000 permits for $10 each. They have not issued a new one since. Literally, there are no more cabs allowed in New York City than there were in 1937. Okay? A typical taxicab medallion, which sold for $10 in 1937, now sells for $400,000. Now, once again, you typically won't sell, you typically rent it out. But the point is that taxicab medallion, which embeds the entire future stream of having the right to drive that taxicab, is worth $400,000. So what have we done here? What we've done, and in Boston, by the way, taxicab medallion is worth about $250,000. Think about that next time you're standing in the rain waiting for a cab. Okay? Next time you stay in the rain for a cab, it's because some guy in 1930-something got a grant for the government worth $250,000. But the current cab drivers don't get crap. Okay? A taxi cab driver in New York City makes $10 to $12 an hour. It's not a very fun job being a taxi cab driver in New York City, unless you like taking your life in your hands every time you go out in the streets of New York City. Okay? They make $10 to $12 an hour after paying the enormous amount they have to pay to rent their taxi cab medallion. Now, this is not the only example we have in the world of something we call occupational restrictions. There's lots of examples. Probably the most prominent example may be relevant to some of you. I hope the taxicab driver won't be relevant to you guys. But the doctor example might be. A great occupational restriction is the AMA and the institute that educates doctors puts a limit on the number of medical residency slots that determines how many doctors there can be in America. As a result, we all pay more to go for our medical care than we would if more doctors were allowed. Now you might say that's outrageous, but why? Obviously, how would the AMA defend this? How would you defend any occupational license? Yeah?
The smaller number of people would be better qualified.
Yeah, you don't want everyone being Dr. Nick, right? You want, come on, you guys got to get Dr. Nick. How many guys, raise your hand if you know what I mean by saying Dr. Nick. Good Lord, what is wrong with you people? Okay, you guys have, okay, The homework for this course, you got to watch one episode of The Simpsons, okay, before the end of the term. This is crazy. Okay, Dr. Nick is the terrible doctor on The Simpsons. Okay, you don't want this terrible doctor. You don't want these terrible doctors operating on people, so we have these restrictions to make sure doctors are good. And it sounds like a good idea. But next time you hear it, remember, it's not just making sure there are good doctors. There are probably plenty of people who would be good enough doctors who aren't let in because they're not in slots. It's also to make sure doctors earn lots of money. And it's not just the government does this. There's no government involvement here. These are private associations which license. Okay? And they restrict plumbers and doctors and optometrists and all these other things are limited ostensibly to keep quality up, but in reality often to make sure that there's some surplus being earned by this initial generation that puts them in place. Yeah?
So is the relative effect on the market smaller for like the doctors because they're not like selling each other their permits?
Well, see, what's different with the doctors is since it's not a permit but an ongoing limit, then every doctor makes the pie. There's no selling. So the effect on the market is no different. So imagine here, instead of it being a medallion, it was a limit on how many cabs could run. And that limit was randomly reallocated. Okay, cab ran out and then new people went in. Then each generation you wouldn't get the thing when the first generation wins. Each generation wins, but you'd still get the same distortion in the market. The same profit being made. It's just instead of the profit all accruing to the first generation, it would be an ongoing accrual of that profit to each generation of doctors. Yeah?
Are professors and tenure, is that also related to?
Professors and tenure would be another very good example of basically an occupational restriction. I think the difference is there's no limit to how many tenured professors there can be. So basically, there's no sense in which, if there's more demand for education, a university couldn't start up and have tenured professors. There's no sense in which a university couldn't just say, we're giving tenure to Tom, Dick, and Harry who walks in off the street. There's no stopping that because tenure is determined by the institution. So in that sense, it's not an occupational license because there's no board which determines tenure standards. Thank goodness. All right? OK. Good. So we'll come back. So that's what we're talking about welfare review this morning's section on Friday. On Wednesday, we'll come back and talk about monopoly.